get the other recorder going here. There we go. And let's take a look at factoring polynomials. Now, there's more than just factoring polynomials on here, but this is kind of a review. These are some basic skills you should know going into calculus for business and economics. First thing we'll talk about is the quadratic formula. Quadratic formula is when you have a problem of the form ax squared plus bx plus c equals 0, and you want to solve it. You want to find out what values of x cause that to be true. Have to have 0 on one side, and then a, b, and c are typically numbers. Then your answer is negative b plus or minus square root of b squared minus 4ac all over 2a. Let's look at a problem dealing with that. It says use quadratic formula to find all real zeros of the second degree polynomial. We got x squared minus 8x plus 3. Now to find all the real zeros, to find zeros means you set it equal to 0 to begin with. So this is in the right form. Now a is going to be whatever numbers for our x squared, which is invisible 1. B will be whatever numbers in front of the x, which is negative 8. And c is our number at the end, which is 3. Now, if you're just learning the quadratic formula, it's a good idea to go through and everywhere you have a variable, put in a set of parentheses. Everything else remains exactly as is. You just replace the variables with parentheses. Or if you mess up on signs, this is a really good thing to do. Well, now everything else remains the same. The negative, the squared, negative minus 4, the 2 down below. Now everywhere we have a b, we'll put in negative 8. Everywhere we have an a, we'll put in 1. And everywhere we had a c, we'll put in 3. Well, negative negative gives us a positive 8, plus or minus. Negative 8 squared is 64 minus 4 times 1 times 3 is 12 over 2. Which gives us 8 plus or minus 64 minus 12 gives us 52 over 2. 52 is 2 times 2 times 13, I believe. Yeah, over 2. Remember, with a square root, we're looking for a pair of whatevers. Here's a pair of 2's. That pair of 2's is going to come out in front as a single 2. So we've got 8 plus or minus 2 square root of 13 over 2. Now if you can divide this number, and this number by the same number, do so. They're all divisible by 2. So that gives me 4 plus or minus 1 square root of 13 over 1. Which gives us 4 plus or minus square root of 13. And that's our answers. Okay, so that gives you an example of the quadratic formula. If I'm working a problem down and we get it in this form, 5 plus or minus square root of 7 over 10. A lot of people will try to simplify this, but you can only simplify it if it's all three numbers. It should be called the three-number rule. And that's what I mean by this over here. It has to be the 8, the 2, and the 2. Can't just be 2 of them. It has to be all 3. So this one actually has simplified as it gets. Sometimes you'll factor out, or not factor out, but you'll bring out an I, and you get this. Well, typically, what we would do, let me show it, is we'd split this up. We want a real part separate from the imaginary, so put 6 over 3, plus or minus, square root of 2 over 3 with an I to the side. But you're going to find in business calc, I's don't have a whole lot of meaning. When you're going to get a profit? Well, after 5i years. That doesn't make any sense. So sometimes when you work on a problem, these indicate steps you can't see. You get it down to something looks like this: 5 plus or minus 1 over 10. Here it's beneficial for you to split it up. What the plus or minus means, it means you got 5 plus 1 over 10, and you got 5 minus 1 over 10. Well, if we simplify, 5 plus 1 is 6, so we got 6 over 10. 5 minus 1 is 4, so we got 4 over 10, which gives us 3/5 and gives us 2/5. So you may find it beneficial to split them apart if you don't have any radicals left at all. Now, if you have a radical left in there, you're probably not going to find it beneficial to split apart. Like this first example we did, 5 plus or minus square root of 7 over 10. You accomplished nothing by breaking it apart. And that's the quadratic formula. Let me save that. What's this called? Factoring polynomials. So factoring polynomials, page 1. Okay. Let's talk about factoring now. We have our first method. I'll put a little asterisk by this because we should always try to do it. Is GCF. And that stands for greatest common factor. So greatest common factor. 2, our second method, is grouping. And use this when you have 4 or more terms. Our third one is the PSD. And this is when you have the form x squared plus bx plus c. The key here is we have x squared, x, no x, and there's no number in front of the x squared. Then we have the key number. And this is when it's of the form ax squared plus bx plus c. And the key here is you have an x squared, x, no x, and there's a number in front of your x squared. And then we have our dots. That's a difference 2 squares. This is 2 terms with a minus between them. They don't technically have to be terms, they can be anything. So if you have 2 anythings with a minus between them, then that would work. Now those first 5 are the important ones. These last 2 are not so important. 6-1 is the difference of 2 cubes. And this is when you got 2 terms with a minus between them. And then our 7th one is the sum of 2 cubes. This is when you got 2 terms with a plus between them. So 2 terms with a plus between them. Okay, let's look at these. Look at these problems. Dealing with factoring. Oops. Let's see. We got 8x minus 64. Now our first method is GCF, greatest common factor. So we're going to try to factor out what they have in common. Number-wise, we look at the 8 and the 64, and we look for the largest number divides into both of those, which would be 8. Now, factor means divide out. So 8 divided by 8 is 1 with an x, minus 64 divided by 8 is 8. Now, that 1 becomes invisible, so this is 8 times x minus 8. And that's our answer. Next one, we got 4x to the third minus 12x. Well, number-wise, we first look at our numbers, the 4 and 12, and think of the largest number divides in both those, which would be 4. Now we have x to a power and x to a power. Now I want to factor out the most x's I can, but I can't factor 3 of them out if this one only has 1. So in this case, we're just going to factor out a single x. It's always the one with the smallest exponent, and if the word put an exponent here, there's like a 1 here. Well, 4 divided by 4 is 1. I tell people learning this for the first time to kind of visualize it. You got 3 x's sitting on a table. Somebody comes up and takes one of your x's. You're left with 2 x's. Minus 12 divided by 4 is 3. I had 1 x there, and somebody went and took it. So there's no x's. So our answer is 4x times x squared minus 3. Now the next one has a special note that goes along with it. Let me write the note down first. It says if your first term is negative, always factor out a negative. So if your first term's negative, always factor out a negative. So we got negative 7x minus 21. And again, the first thing I noticed is the first term is negative, so I'll bring out a negative. 7 and 21, largest number divides in both of those is 7. So we're going to factor out a negative 7. Well, negative 7 divided by negative 7 is positive 1, and that x remains. Negative 21 divided by negative 7 gives me a positive 3. So our answer is negative 7 times x plus 3. Get a drink. Let's look at this one. I got x squared minus 12x plus 32. Come up here. GCF, there isn't any. Grouping is 4 more terms. That doesn't fit. PST, x squared x, no number in front of the x squared. Well, that fits. X squared x, no number in front of your x squared. With the PSD, we take the number at the end, which is 32, and we write it over here. And we would ignore signs. If that was a negative 32, we would still just write 32 down. Now we're going to come up with 3 columns. Come up with our P column, our S column, and our D columns. P stands for product. The S stands for sum, and D stands for difference. Now in the product column, we're going to write all the products give us 32. We got 1 times 32, 2 times 16, 4 times 8, 5, no, 6, no. I guess that's it. In the sum column, we're going to add those together. 1 plus 32 is 33. 2 plus 16 is 18. 4 plus 8 is 12. In the difference column, we're going to subtract them. 32 minus 1 is 31. 16 minus 2 is 14. 8 minus 4 is 4. Now the number we're looking for is always the number in the middle term, which is 12, which is right here, which means I'm going to use 4 and 8 in my answer. So put a 4 there, put an 8 here. Now we have a note that goes along with the PSD. It says the larger number in the P column is always the same sign as the middle term. Now, I'm saying when I say larger number p column, I'm talking about the numbers we're using. So larger number is 8, and it's always going to be the same sign as the middle term. Middle term was negative, so this will be a negative 8. Now, let me write this down. S for same signs, D for different signs. If the number you circled in the S column, that means you're going to use same signs. They'll both be positive, both negative. If the number you circled is in a difference column, it'll be D for different signs. S for same, D for different. Different signs means one will be positive, one will be negative. Now the number I circled is in the S column, which means same signs. So if the 8 is negative, then the 4 has to be negative. And that'd be my answer. X minus 4 times x minus 8. Let's look at another one of those. We've got x squared minus 6x minus 40. And again, GCF, there is none. Grouping, 4 more terms, no. PSD, x squared x, no number in front of the x squared. That fits. So we're going to use the PSD method. We'll take the number at the end, the 40, ignoring signs, and we'll come up with our columns. Write down all products, give us 40. 1 times 40, 2 times 20, 3, no, 4 times 10, 5 times 8, 6, no, 7, no, 8, no. Oh, actually, we're gone back. That's why I say no. Add 1 plus 40 is 41. 2 plus 20 is 22. 4 plus 10 is 14. 5 plus 8 is 13. Difference column. Subtract them. 40 minus 1 is 39. 20 minus 2 is 18. 10 minus 4 is 6. 8 minus 5 is 3. Number we're looking for is number in a middle term, which is 6, which is right here, which means we'll use 4 and 10. Now our larger number in the P column, which is a 10, is always going to be the same sign as the middle term. Middle term is negative, so that one's negative. Now the number I circled is over to the difference column, D for different signs, so if the 10 is negative, then the 4 has to be positive. And that's our answer. And probably don't have room for the next one, so let me save that. And get a new sheet going. Okay. Let's look at number 7. We got 8x squared plus 10x minus 3. Okay. GCF, there isn't any. Groupings 4 or more terms, that doesn't fit. PSD, it's close. X squared x, no x, but there's a number in front of our x squared, so it's not PSD. Key number. X squared x, no x, and there's a number in front of our x squared. So this is the key number method. With the key number, we take the number at the beginning times the number at the end, ignoring signs. So 8 times 3, and that gives us 24. Now we're still going to build a PSD table. We're just going to use it slightly different. I want to write down all products and give me 24. So I got 1 times 24. 2 times 12, 3 times 8, and 4 times 6. We want to add those together. Sum column. 1 plus 24 is 25. 2 plus 12 is 14. 3 plus 8 is 11. 4 plus 6 is 10. In the difference column, we want to subtract them. Smaller from larger. 24 minus 1 is 23. 12 minus 2 is 10. 8 minus 3 is 5. And 6 minus 4 is 2. Now the number we're looking for is a number in our middle term, which is 10. Now we got 2 10s. What you do is you try one, see if it works. If it doesn't work, it's the other one. Once you get more comfortable with signs, this sign here at the end on your last term will help you decide which 10 to use. I'm going to pick this one. The only thing they'll give you a negative here at the end is when you got different signs. If you had a positive here, you'd use the one in the S column. And like I said, we're going to do something different with it than what we did before. Before we just wrote our answer down. Here we're going to rewrite our middle term using these two numbers. Our note on the sign still holds true. So our larger number in the P column, which is 12, will always be the same sign as the middle term, which is positive. So I got plus 12x. Now the numbers I circled in the difference column, D for different signs. So if the 12 is positive, then the 2 has to be negative. Then I want to factor by grouping. With factor by grouping, we group the first two together, group the last two together. Now looking at only the first group, you ask yourself what the GCF of it is. And they have a 4 and they have an x in common. And that gives us 2x plus 3. Then we look at just our last group, and we look what they have in common. They have nothing in common, but my first term is negative. Whenever your first term is negative, you always want to factor out a negative. So factor out a negative 1, and that gives us 2x plus 3. Our goal is to get this parentheses the same as that, which it is. So I'll factor out the 2x plus 3, and that leaves us 4x minus 1. And that's our answer. Let's look at another one of those. We've got 20x squared minus 12x plus 1. Okay, GCF. There isn't any. Grouping. 4 or more terms. No, this is 3 terms. PSD doesn't work because there's a number in front of the x squared. Key number. X squared, x, no x, and there's a number in front of our x squared. So we're going to use key number again. We'll take our number at the beginning times the number at the end. So 20 times 1, which gives us 20. We're going to build a PSD table based upon 20. So we got 1 times 20, 2 times 10, 4 times 5. Add them. 1 plus 20 is 21, 2 plus 10 is 12, 4 plus 5 is 9. Subtract them, the difference column. 20 minus 1 is 19, 10 minus 2 is 8, 5 minus 4 is 1. The number we're looking for is the number in our middle term, which is 12. So we're going to use 2 and 10. Remember, we're going to rewrite our middle term using those two numbers. Our larger number, which is 10, is always the same sign as the middle term, which is negative. Now the number we circled is in the S column, S for same sign, so if the 10 is negative, the 2 has to be negative. And then I'm going to factor by grouping. Group the first two terms together, group the last two terms together. Looking at only the first group, the first two terms, they have a 10 and an x in common. And that leaves us 2x minus 1. Now the second group has nothing in common, but my first term is negative, so we'll factor out negative 1. And that leaves us 2x minus 1. Now, even if they didn't have anything in common, even a negative, you can always factor a positive 1 out, which you should. Well, these both have a 2x minus 1, so I'll factor that out. And to see what goes in your second set of parentheses, you can just cross these out. And then that what isn't crossed out is what goes in your second set of parentheses. So that's our answer. Grab a drink here. Okay, let's look at this problem. Got 3x squared minus x minus 21x plus 7. As I start going through my different methods that I had listed up above, or in the previous page, first one is GCF. Well, they don't have anything in common. Next one's 4 or more terms. Use grouping. So I group first two terms together, group last two terms together. Looking at only the first two terms, the first group, they have an x in common, GCF-wise. And that leaves us 3x minus 1. Second group, they're both divisible by 7, and my first term is negative. So I factor out negative 7, and that gives us 3x minus 1. Again, our goal is to get these parentheses the same, which they are. So I factor out to 3x minus 1. And you could cross out the 3x minus 1s to see what goes in your second set of parentheses, which would be x minus 7. And that's our answer. Let's look at this one. 27x squared plus 9x minus 6x minus 2. GCF, they don't have anything in common. 4 more terms is grouping. So group first two together, group last two together. Now the first two have a 9 and an x in common, and that gives us 3x plus 1. Second group has a 2 in common, and the first term's negative. So I factor out negative 2, and that gives us a 3x plus 1. Again, the goal was to get these parentheses the same, which they are. So I'll factor out a 3x plus 1. And you can cross out those 3x plus 1 to see what goes in your second set of parentheses. What isn't crossed out goes in there. So we put 9x minus 2 right there. And that's our answer. Let's look at the next factoring one. We got 9x squared minus 4. First method, GCF. They don't have anything in common. Next one, grouping. 4 more terms. Well, this is 2 terms. That doesn't fit. PSD and key number are both 3 terms, so that doesn't fit. 2 terms of the minus trinket. Difference 2 squares. So let's try that. We want to rewrite this as something squared minus something else squared. You look at each individual piece, asking yourself what times itself gives you that. For the 9, that'd be 3 times 3. For the x squared, that's x times x. And for the 4, that's 2 times 2. Now this is actually a formula that almost nobody uses the formula. I'll label that the first set of parentheses F for first, and what's in the last set of parentheses is L for last. The formula is F plus L times F minus L. And again, most people don't use that. Basically, you just take what's in your first set of parentheses, you add what's in your last, and take what's in your first, and you subtract what's in your last. And that's your answer. Let's look at the next one. We got 27x to the third minus 64. Okay, GCF. There isn't any. Grouping, 4 more terms. Nope, doesn't fit. PSD and key number both 3 terms, so that doesn't fit. Difference 2 squares. This fits. 2 terms of minus trinket. But you ask yourself what times itself gives you 27, and there's nothing because we have to deal with integers. So that fails. So we go on to the next method, difference 2 cubes. Instead of trying to write it as something squared minus something else squared, we write it as something to the third power minus something else to the third power. And looking at each individual piece, you ask yourself what times itself 3 times gives us that number or whatever. For the 27, 3 times 3 times 3 gives you 27. For the x to the third, x times x times x. For the 64, 4 times 4 is 16, times another 4 gives you 64. So we were able to write this as something to the third power minus something else to the third power. Now this is difference of 2 cubes. Now I'm going to label what's in the first set of parentheses as F for first and L for last here. And our formula for difference 2 cubes is F minus L times F squared plus FL plus L squared. Now wherever we have an F, we'll plug in 3x, and wherever we have an L, we'll plug in 4. So we got 3x minus 4 times 3x squared plus 3x times 4 plus 4 squared. Well, 3x squared is 3x times 3x, which gives us 9x squared. 3x times 4 is 12x, and 4 squared gives us 16. Now this always looks like you can take it down further, but you can't. There'd have to be a 24 here in the middle term for you to factor down further. So that'd be your answer. And yeah, might have room for the last factoring one. I think this is the last one. Yeah. So we got x to the third plus 27. We start going through our methods. GCF, nothing in common. Grouping, 4 more terms. No, it doesn't fit. There's only 2 terms. PST and key number are both 3 terms, so that doesn't fit. Difference 2 squares and difference of 2 cubes is 2 terms of minus between it. This is a plus between it. It's our last one, sum of 2 cubes. Now we're going to, this is similar to the last one. We're going to write this as something to the third power plus something else to the third power. Possibly. So we ask ourselves, what times self 3 times gives us x to the third? X times x times x. And for 27 would be 3 times 3 times 3. Now label this f for what's in the first set of parentheses, and this is L for what's in the last. And our sum of 2 cubes will be f plus L times f squared minus fl plus L squared. Now everywhere we have an f, we'll plug in x, and everywhere we have an L, we'll plug in 3. So we got x plus 3 times x squared minus x times 3 plus 3 squared, which gives us x plus 3 times x squared minus 3x plus 9. And that's our answer. Now again, it looks like you can take this down further, but there'd have to be a 6x in the middle there for you to factor it further. Let me save that. Now there's different techniques that we're going to see in this these next problems. The first one is the square root property. The square root property says if you got something squared equal to something else. Now the entire left side has to be squared here for you to use this formula. Then you drop off your squared and you put a plus or minus square root around the other side. So let's see how to do that with this problem. So we got x squared minus 16. Now the instructions say find all the real zeros. Well, when they say find all the real zeros, they're implying set it equal to 0. Like that. Well, a square root property, if you're missing your middle terms, yeah, there's no like 5x or 7x here in the middle. We just have the x squared and the number. That's the perfect form for the square root property. We're going to take negative 16 to the right side, and it becomes a positive 16. Take anything across equals, sign changes. Now the entire left side is squared, so our formula says drop off a squared and put a plus or minus square root around the other side. Well, 16 is 4 times 4, and with a square root we're looking for a pair of somethings. So that's a pair of 4s. It's going to come out as a single 4. So our answer is x is equal to plus or minus 4. This one we got x squared minus 7. The instructions again are find all the real zeros, which means set it equal to 0 and solve it. So this again is a square root property, because we can get the x squared by itself real easy. So I'm going to take the negative 7, move it over to the right side. We get x squared is equal to positive 7. Now the entire left side squared, so our formula says drop off the squared and put a plus or minus square root around the other side. And that's actually our answer, plus or minus square root of 7. We have something called a zero factor property. And this says if you got something times something else equal to 0. It's pretty vague, isn't it? But it can be anything. Binomial times a binomial, a monomial times a binomial. I mean, you could have any kind of combination there. But if you got a product and you got it set equal to 0, then you can set each factor equal to 0. So I set P equal to 0 and Q is equal to 0. Alright, let's look at that on this next problem. This is number 16. And we got x squared minus 7x plus 10. And instructions are to find all real zeros. So again, we'll set it equal to 0. Well, this is the PSD method. X squared, x, no x, and there's no number in front of the x squared. The 0 is already on the right side, so that's good. So PSD. Take the number at the end, 10. We'll write down all product to give us 10. We got 1 times 10, 2 times 5. Add them. 1 plus 10 is 11. 2 plus 5 is 7. Subtract them. 10 minus 1 is 9. 5 minus 2 is 3. Number we're looking for is the number in the middle term, which is 7, which is right here. So we're going to use 2 and 5. Now, our larger number in the P column, which is the 5, is always going to be the same sign as the middle term, which is negative. Number our circles in the S column, S for same sign, so if the 5 is negative, the 2 will be negative. Now, zero factor property says if you get 0 on one side and you factor the other side, you can set each factor equal to 0. So we'll set x minus 2 equal to 0, x minus 5 equal to 0, and solve these. Take negative 2 to the right side, becomes a positive 2. Take negative 5 to the right side, and it becomes a positive 5. And those would be your answers. Now we have a power principle. It says you can take both sides to a power, basically. Pretty vague, isn't it? Take both sides to a power. But you have to check your answers. Because you'll find that you get the correct answers, but also you may get false answers. For example, here's an equation just as easy as can be. And I'd ask you what the answer is, and you'd look at me kind of funny, because it's already solved, isn't it? The answer is 2. X is equal to 2. Well, power principle says I can take both sides of the second power. Well, that'd give us x squared equals 4. Now, if you remember, when you deal with polynomials, your largest power of x tells you how many answers you're going to have. Since this is the second power, it means I'm going to have 2 answers. Well, if I solve this through, I'll get 2 answers, but only one of them is actually correct. So keep that in mind when you're working these problems. Let's take a look at number 17. Get x to the third minus 27, and then find all real zeros. So we'll set it equal to 0. Well, first thing we have to do is we have to get part this to a power by itself. So I'm going to take negative 27 to the right side. So we get x to the third is equal to positive 27. Now I want to get rid of that power. I just want to have x there. I want to write it in fraction form. So we'll put 3 over 1. Now how we can eliminate any exponent is raise both sides to a power equal to the reciprocal. So this is 3 over 1. I'm going to take both sides to the 1 over 3 power. like that. And the 3 is going to cancel there. And we get x is equal to, and the 1/3 power is the cube root. You'll see that a lot in this class. Again, whatever number is here in your denominator, the 3 is your index. And that 1 would be your power right here. Well, cube root of 27. With an index of 3, it means we're looking for a set of 3 of something, which works out nice because 27 is 3 times 3 times 3. So our answer would be x is equal to 3. Now this next one, we got x to the 4th minus 81 equal to 0. And again, we want to get the part as to a power by itself. So I'm going to take negative 81 to the right side. So we got x to the 4th equals 81. And I want to write the 4 in fraction form. So it's 4 over 1 equals 81. And we're going to raise both sides to a power equal to the reciprocal of that. So we're going to take both sides to 1/4 power. Like that. Now, specifically on this problem, we're going to put a plus or minus. And I'll come back to that. Those 4's cancel there, 1's cancel, we're left with x. And this would become plus or minus 4th root of 81. Well, index is 4, so we're looking for a set of 4 of something, which works out nice because 81 is 3 times 3 times 3 times 3. Index is 4, here's our 4 3s, so the 4 3 is going to come out in front as a single 3. And we get x is equal to plus or minus 3. Okay, we put a plus or minus on that one, but the previous one we didn't. Why? Well, up here, when we had it in fraction power form, rational exponent, the number on top is odd. If the number on top is odd, there is no plus or minus. And that's when it's in fraction form. Now in this other one, once it was in fraction form, the number on top was even. So put a plus or minus. That's going to be your whole driver. If the number up on top's even, put plus or minus. If it's odd, don't put plus or minus. And let me save that. Get a drink also. There we go. And let's take a look at this. We got 19 is x to the 3rd plus x squared minus 17x plus 15. And this says find all the real zeros of the polynomial using the graphing calculator. To find all the real zeros means we'll set it equal to 0. Now, we're going to put this on y1, and we're going to put this on y2. So let's take a look at this. And I have to kind of clean this up. I was doing some trig. Okay, then zoom, and then z standard. There we go. Okay, so we're going to press y equals. Press clear to clear out whatever's on y1. And we got x to the 3rd, so we'll do x caret 3 plus x squared minus 17x plus 15. And we'll down arrow, and we'll put 0 on y2. Now, our x to the 3rd means we're going to have 3 answers. But that doesn't necessarily mean that's what we're going to find here. Because it says find all the real answers. X to the third indicates we have 3 answers. They may not all be real. So let's go through our intersect method. If you remember, you do second, trace, choose intersect. So I'd press the number 5 or down arrow and press enter on it. It'll come up and ask for first curve in the lower left-hand corner. You press enter on it. It'll ask for second curve. Press enter on it. And for the guess, we want to input an x value close to what we think our answer is. This looks like -5 or -6. Let me put in -7 and press enter. And I got to get my glasses on. I can't see that for any amount of money. Okay, what's that? -5 is our answer. Well, we got our answers, remember, is where it crosses the x-axis, so we got 2 more answers. So let's do it again. Second trace, choose intersect, enter our first curve, enter our second curve. And this time, instead of choosing an x value close to it, I'll just press 1, because it looks like it crosses at 1. You can actually guess the answer if you want. And yeah, it comes back and tells us the second answer is 1. We got 1 more answer. So I'll do second, trace, choose intersect, enter on first curve, enter on second curve, and for the guess, this time I'm going to use my right arrow key to move my cursor over closer to the one I want to find. It doesn't have to be right on top of it, just closer to it. And then once you get that, then you press enter. And I get 3. Now if it won't let you go past first curve or second curve, it means you don't have 0 on y2. This process does not work unless you have 0 on y2. Anyway, those are our 3 answers. Let's look at the last problem. You got x to the third minus 3x squared minus 17x plus 51. And we're finding all the real zeros, so we set it equal to 0. We're going to put this on y1, and we'll put this on y2. So let's see. I'll press y equals clear. I got x caret 3 minus 3x squared minus 17x plus 51. Now you have to have 0 on y2. You should already have 0 on y2 from before, but if you don't, then down arrow to it, and be sure you put a 0 there. And now I'm going to do second, trace, choose intersect. Our answer is where it crosses the x-axis, which looks like -4, 3, and maybe 4. So let me do enter on first curve, enter on second curve, and let me try -4. I was wrong. Now I'm going to round this to 2 decimal places, so -4.12. And let's find the next one. Looks like 3. So I'll do second, trace, choose intersect, enter on first curve, enter on second curve, and I'll put 3 in. Yep, that's 3. And then let's find our other one. Looks like maybe a 4. So I'll do second, trace, choose intersect. I press number 5. Enter on first curve, enter on second curve, and we put 4 in. And I get 4.12. Now, if we were in college algebra, I would say, no way, don't give me any kind of decimal answers. But this is business calc, and decimals are acceptable. When you think about it, if I'm working in business, and I calculate how many years till we have a profit, and so I tell you, go to my boss and say, okay, it's going to be square root of 23 divided by 3 years before we see a profit. They'll look at you like you're the oddest person in the world. But if you go to them, and I don't know what this is decimal wise, but well, they probably would give you look odd if you said that. But if you told them it's going to be 5.1 years before you see a profit, this is what they click with. So decimals are acceptable in business calculus. They're not in calculus, they're not acceptable in college algebra, but they are acceptable here. And that's the end of that section. So let me save this page. And there we go. And find the recorders. There's one of them. Stop the other recorder too.